Hello, today I am discussing you a force on a current carrying conductor in magnetic field. So this is a magnetic field and it is our conductor of length L and it is placed at angle theta with the magnetic field. So force on a conductor equals to force on one electron into number of electron. So it will come F is equal to I bracket के अंदर वेक्टर क्रॉस वेक्टर v and after solving we will get f is equals to IVL sin theta and so theta when theta is 0 and 180 f is 0 and theta is 90 f maximum is IVL. So L so this is another circuit here that it is so magnetic field and it is in inward direction and it is a wire of length L and it is a radius of R. So it is a hemispherical. So length vector from initial and final end of conductor. So F बराबर I L cross B. Here L is 2L, so it will come 2L B sin theta because the angle is 90. So here F is equal to I 2R B. So you can see in this figure that it is also angle theta and length L and this is also angle theta and length L. So here is theta is 0 means it is in the direction of magnetic field. So F is equal to IVL sin 0 and it will become F will come 0. Now we will discuss force between two parallel current carrying conductor. So these are two parallel current carrying conductor. So they are separate at a distance. It is a AB and CD. There are force on one F1, force on two F2. It is I1 and I2. That will become repulsion. And you can see also A and B and C and D and force on one F1 F2 can't I1 I2 flow at a distance R, then it is comes at attraction. So there are two type of force, same force attraction, opposite force repulsion. So it will come F upon L is equals to mu naught upon 2 pi I1 I2 upon R. Mu naught is equals to 2 into 10 power minus 7 Newton प्रति ampere square. 1 ampere. If I1 I2 is equals to 1 ampere, R is equals to 1, then F upon L बराबर mu naught upon 2 pi is equals to 2 into 10 to the power minus 7 Newton प्रति meter. Now we will discuss cyclotron. So this is a structure of 2D. So a device which accelerates the charged particle alpha, deuteron, p, this type of. So here it is a magnetic field inward direction and this is a D. So particle move and move, then strike to a target. So this is a D2. So F is equals to QE बराबर MA. So this is a oscillator. So K max is equals to half m V max squared. So it is increased when velocity increase. So after solving you will find out K square V square R square upon 2m. So when m decrease it will maximum kinetic energy will increase. Okay. In this circuit electric field is perpendicular to magnetic field. Here E is accelerator. Here E accelerate and B is a circular path. So radius is R is equals to mb upon qb. Time period is t over 2 pi m upon qb. And frequency is 1 upon t. So it will become qb upon 2 by m. Condition of resonance is f naught upon f is equals to qb upon 2 by m. Now we are discussing our limitation. So E can't be accelerate through E minus can't be accelerate through the cyclotron. For electron, m is decrease, kinetic energy increase, velocity increase. So m is equals to m naught upon under 1 minus v square upon c square. Here velocity is nearly equals to velocity of light. M is equals to m naught. So f is not equals to fc. V do not can't be increased to very high. And it can be not remain in neutral state. So now we are discussing about torque on a coil in a uniform magnetic field. So it is a it is a uniform coil, and it is situated at two magnet, that is N magnet and S magnet, that is B. So force F will work upward, then downward, then up, in and out. So torque is tau is equals to NIAV sin theta, and we know that I dot A is equals to M, so tau is equals to MB sin theta. Vector tau will become M cross V. So this is a force F1, then a force F2. This is a force F1, force F2. So F net is equals to 0, means no linear motion. That means torque net R cross F is equals to 0, means rotational motion. Okay. Then but when F is 0, no linear motion, F net is 0, means no rotational motion. Now this is M is equals to NIA, it is a magnetic dipole moment. This is important, and so net it is a magnetic dipole, which is plus M minus M NS I, then it is E. So M is equal, capital M is equal to M cross 12. This is a pole strength, and capital M is equal to NIA. This is the right hand thumb rule, and mu is equals to EBR upon 2. Then tau is equals to M cross B, tau is equals to MB sin theta, tau is equals to P cross E, tau is equals to P cross E sin theta. So angle between perpendicular direction of plane of coil A and B. This is about theta. So M is equals to NIA, N is number of turn, A is area of current loop, strong maybe, shape maybe NE. Okay. Now I am telling about you moving coil galvanometer. So this is its structure. This is a N and S. So this is a coil. So it is a phosphorus branch and mirror. This is a copper wire. So in equilibrium condition, deflecting torque बराबर होता है restoring torque. So NAB is equal to C phi. This is also an important. So moving coil galvanometer, a device which detect and measure small current. Working principle: current directly proportional to torque, torque directly proportional to deflection. Okay. So NAB is equal to C phi. C is torsional constant, phi is deflection angle. So NAB is equal to C phi. I is equal to C upon NAB phi. So I is equal to K phi. And I is directly proportional to phi, where K is equal to C upon NAB. So current reduction factor, galvanometer constant. Now we will study sensitivity. So it is a current sensitivity. So S, we will note it, S base C. So phi upon I, NAB upon C. So figure of merit, directly I is equals to 1 upon current sensitivity. So 1 upon S base में C is equals to I upon phi is equal to C upon NAB. And voltage sensitivity is equals to S base में V, phi upon V is equals to phi upon IR. So it is S base में C upon R. So that it will become NAB upon CR. Now it is about conversion of galvanometer into ammeter. So this is the structure of galvanometer. When we put a shunt in parallel of galvanometer, it will turn into ammeter. In it, I is equals to Ig plus Is, and by it you can get Is is equals to I minus Ig. Okay, so Ig is equals to I minus Is. Okay, ammeter is connected in series with measuring circuit. Okay, a small resistance circuit shunt is connected in parallel to galvanometer to convert it into ammeter. So potential difference between A and B is equal to Ig into G is equal to Is into S. Important. So it Ig is equal to I S upon G plus S. Okay. So after calculating, we will find out Is is equal to I capital G upon capital G plus S. I is range of ammeter. Ig means full deflection current. S means deflection of resistance of shunt. G is resistance of galvanometer. This is not galvanometer. So in ammeter, a shunt is remain parallel to galvanometer. Okay. So in resistance, galvanometer value is greater than ammeter, but in ideal ammeter R is 0, but internal resistance is infinite. Okay, so this is for about all this video. So thank you so much.